Hi guys, I want us to look at the integral of arctan of x with respect to x. So on this integral, we use the same method as that of solving the integral of ln x dx, right? So in this case, what we are going to do is we are going to put a 1 there, right? Because 1 times arctan of x is just arctan of x, so we haven't changed anything. So we're going to choose our u to be arctan, right, of x, right? So after doing that, it means we can get our du over dx, right, as what? Our du over dx is going to be, it's going to be 1 over 1 plus x squared, right? Because that's the derivative of tan inverse of x, right? So we're going to have something like this. Then we're going to say automatically what's left of our integral is our dv dx. So the one that we have there after choosing u as arctan is going to be our dv dx, meaning v is just the integral of 1x to the power 0. We add 1 to the power, then divide by the resulting power. So that's going to give us x, right? This is just x over 1, which is just x. So after that, we write our formula for integration by parts. The integral of u dv over dx. So the question comes in this form, right? U dv dx equals uv minus the integral of v du over dx, right? Then we're going to plug in the terms that we got. We said our question is in the form u dv dx, and we can see that because that one there is 1, right? This one here is u, so it's just arctan of x multiplied by 1, which is just arctan of x, which is exactly the same as our question. So now we are going to put the terms that are on the right hand side, which is the solution side. And this integral, remember, we'll also have to solve it because we don't want any integrals in our solution. So that's going to give us arctan of x, right, multiplied by v, which is x. So uv, right? That's my term. This negative sign is part of the formula. I also put it there. Then I'm going to put the integral of, if I look at, so I have v du dx. If I multiply those, I get x over 1 plus x squared. So that's going to be my v du dx, x over x squared plus 1 dx. So here, I might choose to use u substitution, but there is a rule, there is a concept called the recognition aspect of integration, where you recognize that you have a denominator that is a function of x, and if you derive it, meaning if, so we're saying if you have f of x, if you have the integral, so let's just do this. So let's say you have something like f of x, right, over g of x with respect to x. And you recognize that g prime of x is equal to, so we're saying if g prime of x is equal to f of x. So basically, if the derivative of the denominator is equal to the numerator, then the solution to this integral is going to be, so we're saying then the solution to this integral is going to be ln of modulus of g of x. So that's plus our constant of integration c. So that's the recognition aspect of integration. So if you look at this one, if we derive the denominator, we get 2x, right? But on the numerator, we have x. So what we will do here, we will manipulate this so that it suits what we want. We get a 2 here. But remember, if we put a 2 there, we have changed the question. That's what we want to avoid. We want to avoid changing the question. So if we put a 2 there, we'll also cancel it out by multiplying by 1/2. Half of 2 is just 1. So you haven't changed anything. So that's just going to give you half of 2x, which is just x over x squared plus 1. Now if you integrate this, forget about the constant, integrate that. We said if g prime of x is equal to f of x, then our solution to this part is just ln of g of x, which is the denominator, right? So this here we're going to write it as ln of x squared plus 1, but we mustn't forget this half because it was there for us to be able to manipulate our integral without changing the question. So our final answer is going to be arctan of x dx, right, equals x arctan of x minus 1/2 ln modulus of x squared plus 1 plus our constant of integration c. That's our solution.